This is Algebra lesson 3.3, and it's titled Rate of Change and Slope. Okay, here's the deal. I know we just watched the film, right? Well, we just watched, but remember a few days ago we watched the film on slope, right? I know you guys thought it was a little bit boring. She was a little bit weird, but hopefully you picked up enough stuff from her that you know, I think I may have even shown you that last year. I think I might have. But anyway, it's important that you understand the basic concept of slope. It's huge for the next 3 or 4 chapters. So here's the deal. The rate of change, okay? We're just going to write this down up here. Rate of change. Another name for rate of change. You know what another name for rate of change is? Slope. The rate of change, another name for rate of change is slope. But we'll get to that, right? If I ever ask you for the rate of change, I'm talking about the slope. If I ever say what's the slope, you could also be talking about the rate of change. They are interchangeable. All right? Anyway, the rate of change or the slope, here it is. Are you ready for this? It is the, do you remember those terms? That's the change in y over the change in x. That's what the slope is. That's what slope is the change in y over the change in x. It's written as a ratio, right? And by looking at the slope, you can tell a lot. In fact, here's the deal. If you have even 1 point on the coordinate plane, if you know even 1 point on the coordinate plane and you know the slope, then you can draw the line. I want you to think about that for a second. If you know even 1 point on your line, any 1 point on the graph, then you could draw me the line if you know the slope. What I mean by that is this. I'm going to do this very crudely. But if you knew that the slope was a 2 slope, and you knew that this point right here was on there, then you can draw slope triangles, right? And find this and draw the actual line. A 2 slope would look like this. And there's our line. This is where I'm going to go way back. I'm going to reverse here in a second. I just need you to understand that if you know even 1 point on your line and you know the slope, then you can draw the whole line. But anyway, let's talk about this. The change in y over the change in x. Couple of things. Before we do anything, we have to determine whether or not it's a line again, right? We're going to determine whether or not data represents a linear equation, okay? We're going to talk about whether or not data represents a line or whether data represents a linear equation. This is what we do. If we have a set of data, in other words, we have made a table, or a table was given to you, and on this table, we have these points, 1, 4, 7, 10, 13, and -6, -8, -10, -12, and -14. We need to be able to tell, based on the data that we have here, whether or not this is in fact linear, or in other words, whether in fact it creates a line. We need to know this. If it doesn't create a line, then we can't write this thing's graph. Then we can't write this thing's equation, right? So anyway, here's the deal. Here's how you figure it out. Each side, both the x and the y, have to have a constant rate of change. Okay, they have to be consistent. Over here on the x, what is happening when we go from 1 to 4? What's happening? It's up 3, right? When we go to 4 to 7, what's happening? Up 3. 7 to 10 is up 3. 10 to 13 is up 3. At least on the x's side, it's consistent. Now, here's the deal about this, and you need to understand this. You are always going to be able to make the x side consistent. You just will. How do you know that you're always going to be able to make the x side consistent? Is because who's choosing the x's? You are, right? So you're going to be able to go 1, 2, 3, 4, 5, or -2, -1, 0, 1, and 2, like we've done in the past. Or you can go 5, 10, 15, 20. You get to pick the x, right? So yes, it needs to be consistent. But it's always going to be consistent because you're going to get to pick the x. Does that make sense? Okay. But in this case, it's consistent. Good. Over here on the y, what is happening? It's going from -6 to -8, which is minus 2. Negative 8 to negative 10, minus 2. Negative 10 to minus 12, negative 2. It's okay. Are these the same? Are these the same? Are they consistent? Yes, they're consistent. Therefore, we know this is linear. We know this creates a line. Knowing that it creates a line, we can now find the slope. We can find the slope of our line. Here's what we do. Remember, what is the slope? What is the formula for finding the slope? The change in y over the change in x. What is the change in y? What is the consistent change in y? Negative 2. What is the consistent change in x here? The slope then, we don't leave it like this. What would I do to find the slope? It's negative 2/3. That's the slope. The slope of this line is negative 2/3. We know it's a line. How? How do we know it's a line? Because we looked at both the x's and the y's were consistent. Right? If even one of these things, if this would have been minus 3, then it's not a line anymore. And on our graph, it would have looked like this. Instead of it being a line, it would have been like beep, boop, boop. Make sense? Or something like that. It would not be a line. It would jerk over a little. Okay? Let's look at another one. Let's look at another one. Oh, let me draw my table so that there can be no confusion. What, do you remember this? Can I put f of x there? Right? F of x and y are the same. But okay, we won't. We'll just reminded you of that. Okay, we'll get to that later. X and y. X, negative 3, negative 2, negative 1. 1 and 2. And then we have 11, 15, 19, 23, and 27. In this situation, you tell me if this is linear. Most of you can look at that and tell me whether or not that's linear or not. Is it linear? No. What happened? The x's are not consistent. This is plus 4 every time, right? These are all plus 4s, but when you created this thing, what did you forget to do? There's no 0 here, right? This is plus 1, plus 1, plus 2, plus 1. That's no good. That means that this is not a line. Okay? Not a line. Not consistent. Those are not the exact same, and those are not the exact same. No linear. You can't write a slope when the only time you can write a slope is if the equation is linear. Right? The only time you can write a slope is if it's linear. Okay? What about this? What if I have another table here? And I have 12, 9, 6, 3, 0, and negative 4, 1, 6, 11, and 16. What do you do? How do you do this? What have you seen me do? Whenever you see me do something, that's what you need to kind of get in the habit of doing. What do I do at this point? I look at the x's and start making these little rainbow things, right, to see how does it go from 12 to 9? Minus 3. What is 9 to 6? Minus 3. 6 to 3. Minus 3. Minus 3. The x's at least are consistent. Okay? The y's, what is negative 4 to 1? What happened there? That's plus 5. Oh, this is plus 5. Oh, plus 5. Oh, plus 5. That means that this consistent, that makes this whole thing linear, right? It means it's a line. It's linear. Okay? What is the slope of my linear line here? Change in y over the change in x. What is the change in y? 5. What is the change in x? Minus 3. Is that how you write a slope? No, you need to put the negative out front. Negative 5/3. There's our slope. Okay? That's how you do this. That's what you do. If you are in any way like, I'm not sure I'm going to remember this, what should you be doing at this very moment, right here with this right here? Write it down, right? You should be writing this down. If you don't plan on writing it down, then you're planning on going back and watching this on YouTube tonight, right? Because you got to have this. You've got to know how to do this. Okay. Another way of finding slope, or the rate of change, is if I gave you 2 points on the coordinate plane. One, I could do this. I could actually I could actually draw my coordinate plane and give you 2 points. We'll go right here and right here. And, you know, you could figure out the slope. First of all, here's the deal. Watch what I'm doing here. Watch this. One thing I could do here is this. Literally from the graph, I can go, okay, the change in y. What does that mean when I say change in y? It means when I change in y, is that going up and down or side to side? Change in y is up and down, right? So change in y is up and down. From this point here to this point here, what did I do to go from here to here on the up and down? I went up 3, right? From here to here, I went up 3. Does that make sense? 1, 2, 3. I went up 3. Does that make sense? To go from now this point here, or actually what you would do is you'd go from here to here, right? It went from here to here. What did I do? I went to the right 2. Going to the right, we've been doing this your whole life. Which going to the right is up or down. When you go on your number line, if you go from here, right here's 1, 2, 3, 4. What is going to the right? It's going up. Right? It's going up. So when you go to the right 2, when you go from here to here, to the right 2, that is up 2. Does that make sense? Okay. What is our slope? What is our slope here? It's the change in y over the change in x. What is our slope? 3 over 2, right? Our slope is 3 halves. We went up 3 and over 2. Make sense? We've done this before. Let's see. Let's try another one.
Is that also right?
Nope. Look here. So you're right. It isn't negative 3, 2. It would be this. One thing you could do is this. Watch. This is it. This is important. I could go from here to here. Are you all watching here? This is important. To go from here to here, that means that I went up 3 and over 2. Up 3 and over to the right 2. Both positive. What if I wanted to go from right here? I'll do this in green. What if I wanted to go from here to here? Well, to go from here, I went down 3, and I went to the left 2. What's to the left 2? Minus 2. What is negative 3 over negative 2? A negative over a negative is a positive, which is still 3 over 2. It doesn't matter which one you start at. Your slope is the same. This slope right here, this is important. This slope right here, honestly, that slope is 3 over 2. I don't care where you are on the number line, or where you are on the line, it's 3 over 2. What happens if on this exact same thing, watch what I do here. What if I did this? Okay, that's still on the line. And I went from, I want to go from, I'll make it purple. I want to go from right here, which is on the line, down to right here, which is also on the line. Does that make sense? It's the same line. Do you agree that I'm still on the same line? Let's do it. I'm going to go from here to right here. How does it go from here to here? Well, you have to go down one. Let's see. You have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. Minus 9. I went down 9. And then from here I went 1, 2, 3, 4, 5, 6. To the left 6. Left is negative. Minus 6. What is the change in y would be negative 9 over the change in x, negative 6. What is negative 9 over 6? That is a positive 9 over 6, which reduces to 3 halves. It's still the same slope. I don't care where you are on that line. You choose 2 points on the line and the slope is 3 halves. Does that make sense? It doesn't change the slope. Wherever you're at, doesn't change the slope. This slope right here is 3 halves. Whether it's way down there or way up, this slope right here is 3 halves. Make sense? Okay. Let's look at, okay, so here's the deal. I'm going to go back to this really quick. Let me go back to this whole thing here. It's going to go back to the original question. So that is one way of finding the slope, is to literally graph it on the coordinate plane. Okay? That is one way to do it, is to literally graph it on the coordinate plane. You're not going to want to do that hardly ever. You know why? Because it takes a while, and you have to get a ruler out, and you got to get, and it takes a long time, and a lot of times you're not going to be accurate enough. You just won't. You know what I mean? You getting a ruler out and doing this is not going to be super accurate. For now, we're doing it so that you understand the concept, but you won't do this very often. You'll think this is the easiest way, and it is not even close to the easiest way. Here's the deal. Let's find, what is this point right here, by the way? What is that point? Somebody tell me that point. It's 3, 4. Here's 1, 2, 3, right? Right? And then 1, 2, 3, 4. You see how it's 3, 4? Okay. That is point 3, 4. What point is that? That is point 1, 1. Okay. Another way of doing this, especially if the numbers are big. If you've got big numbers, you're certainly not going to want to graph the point 34, 17 and negative 16, negative 50. Do you agree that you're not going to want to graph that and then draw slope triangles and figure out the slope? You're not going to want to do that. So here's another way of figuring out the slope if you know 2 points. One, you could draw the slope triangle like we did, or remember, it's the change in y over the change in x. We have to choose one of these points to be point 1, and we have to choose one of the points to be point 2. Let's make this here point 1, and we'll make this here point 2. Does that make sense? I've just chosen that. I could reverse it, and it will still be the same. We've already learned that, right? No matter which one I start at, the slope is still 3/2. But I'm going to show you the other way to do this. This is point 1, and this is point 2. Okay. Change in y over change in x. We're going to go right here. It is y. Isn't it y2 minus y1? Let me look really quick. She did it like this, and so I'm going to do it that way too. Here we go. You go like this. y2 minus y1 over x2 minus x1. No. Just memorize this. The change in y over the change in x. In other words, we're going to take point 2 and take the y from point 2 and subtract point 1, and then take the x from point 2 and subtract the x from point 1. Let's plug this in now. What would y2 be then? Which one is y2? This 4. Do you agree with that? That's the y in point 2. Agreed? So 4 minus, put in parentheses by the way, 4 minus, what is point 1? What is the y in point 1? 1. Over, what is the x in point 2? 3 minus 1. What is 4 minus 1? What is 3 minus 1? Do you remember what our slope was for this? 3/2. Does that make sense? Should you memorize this? y2 minus y1 over x2 minus x1? Yeah. If you don't have that memorized, you should be writing that down. That's important. Now, what if, let's do this backwards. Let's switch this around. You know what I'm going to do that's going to really throw a loop into things? I'm going to make this be point 2 now, and this be point 1. Okay? We're going to switch the points. Let's try it again. It goes y2 minus y1 over x2 minus x1. What is y2 now? No. What is x2 now? What is the x in point 2? 1. In parentheses. Minus, what is the x in point 2? Sorry, in point 1. Sorry, it's y2. What is the y in point 1? 4. Over, what is the x in point 2? 1. Minus, what is the x in point 1? What? Yeah, x in point 1. Sorry, what is the x? Let me go back, sorry. It should be x2. What is the x? That is 2, I did it right? Right, and then x2. What is the x in point 1? 3. Does that make sense? What is 1 minus 4? What is 1 minus 3? What is negative 3 divided by negative 2? 3 halves. Does that make sense? Getting myself jumbled. But you can see it, right? You should be able to look at this, and you've picked this. And you need to keep that consistent. On your paper, when you do this, should you write down, oh, this is point 1? Should you make sure you got that and make sure that you know that's point 2? Absolutely. Absolutely. Okay. I'm going to show you a few things, okay? I'm going to show you a few things. Any slope, again, this is review from last year, I know. Here's my coordinate plane. Any slope that when you're going from left to right, are you with me here? When you're going from left to right, when you're skiing from left to right, like that lady in the film, when you're skiing from left to right, if you are skiing uphill, what kind of a slope is that? That's a positive slope, right? If you're skiing uphill, then that's a positive slope. If you're skiing downhill, then it is a negative slope. Here's the two that are a little tricky. What happens if you are skiing and there's like this? Remember, it's a zero slope because the person has zero problem skiing when there's no slope. Does that make sense? There's zero slope, or you could even say there's no slope. Got it? This is a zero slope. This would be 0 over 5, right? If there's no slope. In other words, look here. We'll come back to this, but it's pretty cool. No slope. What happens if you're this? What's the slope there? It's not possible, right? You can't ski like that. You can't ski up or down this way. Therefore, it's undefined. You would call that undefined. That would be like this. Can you have 5 nothings? Right? We've dealt with this before. Can there be a 0 as a denominator? Never. You can't have that. That doesn't make any sense. Remember, this is how many pieces of the pie are left, and this is how many of them there were originally. You can't have 5 zeros, right? Can I originally have had 5 pieces of pie and now have none left? Yes, but you can't have 5 nothings. Does that make sense? And that's where this is undefined. That makes no sense. Okay? You just have to know those terms. Zero slope, undefined. Got to have that memorized. It's that simple. I think that I'm going to if you want to get technical, I've shown you like 3/4 of what you're supposed to do. I'm going to give you some homework now so that you don't have so much tomorrow. Okay? When they ask you for the rate of change, what are they asking you for? The slope. Very nice. Could you tell me the slope based on looking at a graph? Yes. Could you tell me the slope looking at a table? Yes. Could you tell me the slope if you just have 2 points? Yes. Yes. I've shown you all 3 ways to do that, right? I think you're going to be okay. Let's do this. Let me do, let's go page 176. We're going to go 16, number 16. 20, 24, 26, and 28. Before we do this right here, what happens if you come up and your slope looks like this? What if that's your slope? What's your slope? The slope is 1, right? You know the rules. You reduce, and so 3 over 3 can be reduced, right? When do you change it from an improper fraction? What if you have this 6 over 3? Would you leave that? Didn't some of you get in trouble for that? Why? What is 6 over 3? What is the slope of that? That's a 2 slope. The only time you change it from an improper fraction is if it is a... The only time you change it from an improper fraction is if the answer is a whole number. Right? If it comes out to this, 7 over 3, what do you do with that? You leave it. That's the slope, 7/3. If it was 10/5, what do you do with that? What's the slope there? 2. Makes sense? What about this? What if it is 6? What if that is the slope? What do you write that slope as? 3/4. You have to reduce it. Right? Okay. I think you guys got it. There's your homework, page 176. Those 5.